Hi, my name is Theo Krither and I'm a cloud architect at Dell Technologies. In this video, we'll install the CSI driver for Dell PowerScale storage on a Red Hat OpenShift cluster. The versions I've used for this demo are OpenShift version 4.9 that comes with the Kubernetes version 1.22 as default, and I've used the latest version of the CSI driver 2.2.0 with PowerScale 1FS version 9.3. It is important to check the documentation to ensure that each of the components are compatible with each other to avoid any issues during the deployment. You'll find this documented on the CSI driver documentation page as you see here. We'll be using NFS as the protocol, which is supported with the PowerScale CSI driver. So let's get started by preparing the environment. First we install Helm. We're going to use Helm charts to do the install. Then we clone the repository for the PowerScale driver, as you see here. Next, we check that we have access to an OpenShift cluster and we have a number of namespaces created already. We need to prepare a new namespace called Isilon that we'll install our driver into. Once we have our namespace created, we'll prepare 2 YAML files to create our secrets. The CSI driver comes with samples that we'll use as templates, and we'll copy and insert our own credentials into these files. Here we'll provide the cluster name, the username, the password, the endpoint port, and we'll set the skip validation for certificates to true because we're using a self-signed certificate in this lab. And lastly, we'll specify the ISA path as the directory that will be used to create the dynamic volumes on the PowerScale storage system. The driver allows us for connection to multiple clusters, but we're only using one, so we'll remove the second cluster in this file. Now we can go ahead and create that secret, and we can also create a second secret using the sample template for the empty secret as shown here. Next, we'll copy the ISON values file and we'll change a couple of settings here. If you want to change the number of controllers being used, you can change it here. You can change the prefix for the volumes that are created. We're going to only make one change here, and that will be for the authorization type. In my environment, I'm using a session-based authorization, so I'll set that setting to 1 for session-based authentication. So once we save that file, we're now ready to start our driver installation, running the install script. As you see here, it's been ran, it's successful. You should see green success across all components. If you want to verify, you can run the verify script and check to make sure all components are successful. You can then check the pods and make sure all of the pods are running. The controllers and the nodes should all be running state. Now we'll create our storage class based on the sample files provided, and then we'll go ahead and create the volume snapshot class as well with the same sample files. And that's it for the install of the driver. Now we can test it by creating a namespace called test, and then we'll change to that namespace and we'll start by creating a PVC YAML definition file, which we can download from a Git repository I have here. We'll first check what that PVC file contains, and we'll make a couple of changes to make sure it suits our environment if required. Then we'll create that PVC as you see here. Now the PVC is created, we now need to set up a YAML definition for the pod itself. So we'll check if there are any pods. If there's no pods, we'll download another YAML definition file, check what's in that file, make any changes as required. In this case, we're mounting to data 0 path with the pvol0 PV we created in the PVC file. So we'll create that pod, check that the pod is running, and now we're able to test it. But before we do that, we'll just set up a snapshot file as well, because we know that we want to do snapshots on this particular volume. So we'll get a sample definition file for a snapshot, and we'll make some changes to that as required. The test namespace, we'll give it a new name, and then we'll create that snapshot volume as well. Before we run the volume snapshot, we'll just check first that the volume snapshot class is set up correctly. So you can see here Isilon snap class. In our volume, we've specified isolate snap class, and then we're able to go and create that snapshot of the volume. If we check the persistent volumes, you can see the persistent volume there. You can also see the volume snapshot is created successfully as well. So now if we have a look at the storage class isolon, we'll notice the CSI isolon as the provisioner, and we'll notice the ISI path of the directory where we're going to store the volume. Then we look at the definition of the pod. We'll notice that it's running on a node worker 3, and if we scroll right to the bottom, you'll see that the successfully attached volume has been mounted with a volume name dynamically created by the provisioner. Now that we have the pod, we can execute a remote bash terminal, check the mount, see that it's mounted as a dynamic path on the isolon storage array with the data 0 mount point as an NFS 3 version target. We can cd into that path, and we can touch a test file with an editor, and we can write some data to it, hello world, and we can save that file. So we've created a test file on that volume. We can go into the storage array itself in the UI manager, and we can check that it exists on the volume on the PowerScale appliance. Go into File System Explorer, navigate to the directory, find the file. You can see it's 13 bytes in size. We can also check the snapshot that we created earlier and note that this is created by the storage array itself. Thank you for watching this video, and if you're watching on YouTube, don't forget to like and subscribe.